On his shoulders, the fate of the world came to rest. If I remember well, he had to cross the world to drop a ring in a volcano in order to rid it of all evil. Oh, wait a minute, that's folktales. That's easy peasy, but it doesn't work like that. I mean, we're in the real world here, so let me try again. He had to monitor energy consumption in all homes in the whole world to overturn climate change. No death challenge. Okay, let's say we give him a little help, okay? So what about monitoring energy consumption in all homes in all world? And not only per user or per utility company. I'm sure you receive energy bills yourself with such information on it, but we are talking about aggregating per city, per region, and per country numbers, and maybe also per activity, per usage, the number of children, and a lot of other criteria would be useful to be able to know where it actually leaks out. We are talking here about multi-point of view of data. That needs an open world approach of data. We need to be able to stack other point of views as needed in order to track where it leaks out. And this kind of open world approach of data is called linked data. So a little bit of linked data introduction. What is linked data? Linked data is data sets that have been reconciled together so that they can be cross-queried. That's exactly what we need. Here enter OCCIware data core. OCCIware data core is linked data store that holds data that is shared between applications of the OCCIware App Store, such as geographical elements, organization, or any other kind of reusable business app data. It stores it all in a replicated MongoDB and is built on Java. It provides all this linked data through a REST API, which is both web-friendly and semantic web compatible thanks to the JSON LD standard, W3C standard. And it also helps developers with a playground. Here it is, the JSON LD playground of the OCCIware data core linked data store. REST API playground, great. But if we wanted to save the world, it has to scale the whole way up there. At all levels, if we take the 3 cloud traditional layers, at infrastructure level, it means provisioning enough CPU and storage and network for each city. At platform level, well, you needed to be able to deploy your Java code and Mongo clusters on all nodes of the infrastructure. And finally, at software level, that's SaaS. Well, you have to configure linked data governance, which are data models and their kind of use, and specifically 2 kinds of use of linked data here. We first need high write, high performance, therefore non-robust data collection. We need to collect data from all home energy consumption sensors in all worlds. And we need to be able to do any kind of queries, any kind of data analytics, such as aggregating per energy consumer provider, but also city, region, country. Great. Cloud computing will save us. And luckily for our Hobbit, there are well-known standards and solutions in cloud computing. Maybe there is a problem. Yeah, because at infrastructure level, you have several standards such as Open Cloud Computing Interface, DMTF CIMI, and the most used of them all is not even a standard, it's made in AWS. At platform level, no standard at all, too bad, but it doesn't lack of implementations. You have Cloud Foundry, OpenShift, you have GoLab Engine, you have a lot of others, and all obviously incompatible with each other. And finally, at application level, well, that's a free-for-all here. Everybody does it its own way. The glue required to bring it all together and not even business-specific standards here. And it's not like, well, choosing only one single provider for all layers would solve the problem, because there are not that much, and anyway, hybrid cloud is today a given, unless you have a not critical at all or way too critical to go to the public cloud use cases. It's not our case. We need to be able to, well, to use on-premise to store critical data, and we need to be able to use public cloud to burst when we have load peaks. And finally, our Hobbit still has to do the SaaS layer and the whole linked data as a service assembly himself, all the glue, which is a problem. If you want more, you have to add more and use their specific APIs, their specific tools, and I'm not going any way further towards the big noodle plate we've already eaten. But our Hobbit just wants to be a cloud consumer. He doesn't want to be a cloud provider, because there are already plentiful of expert cloud providers. So he just wants to smoke a good pipe. No, he just wants a cloud consumer platform. Is there any cloud consumer platform, please? And now there's a light of hope in this fragmented landscape of layers, APIs, and implementations. There is a hope to bind and control all these cloud APIs, layers, and implementations, and rule them once and for all. Maybe I did mixed up the script here, but anyway, there is one cloud API to rule them all. Please welcome OCCIware and the OCCI API. And this is a Docker-based infrastructure with a cluster of MongoDB, and on top of it some linked data Java code within a VirtualBox virtual machine on the left and OpenStack on the right. And this is on top of the infrastructure. You've got software as a service configuration, which are data projects of the linked data core configured for our required kinds of uses. In Eclipse. Hey, coincidence, we are in EclipseCon. So this is the OCCIware product. This is the OCCIware Studio. And there's also an OCCIware Runtime. It all works. It's not only diagrams, which are both built around OCCI specifications. And obviously, OCCIware Studio is built on Eclipse. And we've got a great OCCIware runtime middleware, scalable at will, written in Erlang, which is Heroku. Yes, it works both ways. But first, let me introduce the OCCI specification. OCCI is very simple. In OCCI stands for Open Cloud Computing Interface. In OCCI, everything is either a resource or a link. At infrastructure level, it means, for instance, compute resources, that's virtual machines, storage resources, that's disks, and network resources. And links at infrastructure level would be storage links that provide a disk to a virtual machine, a storage to a compute. And it goes on at platform level. At platform level, well, you have containers, databases, routers, and database link to provide the database to an application container. And at application level, well, you have an application template or deployable, you name it as you want. Anyway, you get the twist. OCCI is a metamodel and therefore extensible. And that's why it's the only cloud standard to cross all cloud layers and to be able to support potentially all business domains. So it's actually exactly what we need here. There is a funded project sponsored by the French Ministry of Industry, which gathers 3 academics, 5 companies, and 2 associations. 5 companies including OBO and OpenWide, which aims at building on the OCCI specifications to empower it, to base it on formal languages, foundations, to toolify it using the Eclipse platform, and to overall bring it the power of model-driven engineering. And also demonstrate across different domains such as data center, deployment, big data, and linked data. So that's who pays me to be there. And the objective is, as said, to manage everything as a service in the clouds. We could name it XaaS. Not only software as a service, platform as a service, and infrastructure as a service, but also container as a service, data center as a service, and upwards, linked data as a service and big data as a service. All of this is demonstrated in the OCCIware project. So, okay, all of this is very nice, pretty diagrams, pretty pictures, but how did we get there? And there are 2 questions here. What is the approach, technology, the Eclipse technology, and how do you do it? How do I do it? So I'm going to let my friend Etienne here answer the first question.
Yeah, so thanks, Mark. To create a tool to be able to design your cloud systems, we use a great tool called Eclipse, you know? Okay. So first I will show you how we did it. Because there was a challenge, because OCCI is a standard we have to rely on, and this standard has not been created with EMF in mind. So, in the standard, do you know EMF? Not? So EMF is a standard way in Eclipse to represent any kind of data, with plenty of tools on the top of EMF that we would like to reuse. So what we would like to do is that inside OCCI you have the standard, where you can define some entity kind and link. You create your own extensions, for example, for Docker, for your infrastructure, for monitoring, for on the IaaS, PaaS, or SaaS. That's basically REST description of your systems. And here you do it for your dedicated applications, or dedicated infrastructure. So for example, the name of the server, your virtual machine, etc. That's the 3 levels. In Eclipse, you have the same 3 levels. Core, which is a way to define any kind of language, your language, and your models. So, if I try to use, I will have problems, because OCCI is at the same level than Core. Oops. Ta-da. So what we would like to do is to define OCCI with all the classical structure of Core, and to say that an entity is an E-class, a kind is an E-class, a link is an E-class, and there are some reference between them. But if we do this to be in a standard Eclipse way, we'll have problems because we don't have 4 levels in EMF. We have just 3 levels. We can generate any information from your model from this one, but from this one, that's just an XML file at the end, and you have nothing to do. So we don't want to reinvent the wheel and to reinvent all the mechanisms of EMF or to make something complex. So we decide something. I think it's the first time I saw these use cases, is to define the standard inside with Core, your extensions, your Docker domain as an XML file from your own. So you work with all the concepts. You create a new entity, a new kind, a new link. That's a dedicated OCCI domain. And when we are here, we create a kind of promotions. It means that we transforms this XML file as a new domain models. So we generate a new plugins, a new project. We generate a new core, which is completely 100% generated from this one. And after, we can reuse all the existing infrastructure of Eclipse and EMF to do our tools, our dedicated tools. So in this way, we succeed first to be compliant to the OCCI standard. So all the guys where I tried 1 year ago to say to them, oh, please cancel your way you want to do OCCI. There is already core. Try to just use core. Say, no, that's your Eclipse world. I don't want to use it. I want to use my own. So we were succeed to do this with them, but we continue to use all the tools which is already ready to use. So that's quite cool. So we automatize the generation of your extensions. And at the end, we do this for the metamodel, so you can store information in a standard way. And we do also the same for the designer. So in the same step, we generate a basic designer. So you can also have a tools for free, which at the beginning just provide you some boxes that you can move, which simplifies the way you can create your own tools for target the design of your own infrastructure or your applications. So we generate the metamodels from eCore, JModel, and the code from the extensions, and we generate the serious designers. Last, at the end, for the end user, you will have several kind of designers, or we target to have some Docker designers, so something graphically. So it's easier to use than some Docker files. It depends on other Docker files. It depends on other Docker files. This time you have something more graphical. But you can do the same with some classical server mapping for doing cartography. You can do the same for Azure, having an Azure-based designer. Each time they seem to be dedicated, but they are based on the same infrastructure and the same process. So it's quite cool.
And obviously, some standards, Azure won't have all the exact same configuration capacity abilities than, let's say, Google App Engine. For instance, we have in a project a partner called XaaS, which provides data center as a service, and they allow to configure kind of hard drive, kind of storage, such as either SATA or SSD, which is very useful to their customers. And this attribute is not in the generic OCCI infrastructure standard, but other attributes are, such as a host name, for instance. And if you want to share more attributes, well, you can always define what OCCI terms mixins. Those are some kind of aspect-oriented modeling, some kind of parts of the types, grouping several attributes that you can reuse by specifying it on top of an existing resource. So OCCI is quite flexible, and there are ways to have some support for generic attributes, and other specific attributes you can add as you want, including develop your own for your own cloud abilities. So thank Etienne. Now that we have understood how it all works together, I would like to show you a demo of how it's actually done. So I will try to redefine a working extension from the start. So that's a recipe to make it all fail again, but I will try not to delete the original one so I can show you at the end how it works. You can see here it works, okay? So now I'm just destroying it. So how do you develop new extensions such as a linked data as a service extension? Well, very simple, new cloud designer. You've got here a cloud designer category. OCCI extension project, that's exactly what I want. And let's name it org OCCIware cloud designer OCCI linked data. Extension name, no. I already have one, so that's my starting up back from scratch. An extension scheme will be http OCCIware.org linkdata1. And if I wanted to actually reference or inherit resources from already existing, already defined extensions, I could just reference them here. But I don't want to inherit from it. I just want to define my own. So here I have the OCCIware OCCI extension designer. So what I want is not only work with resources, but with linked data resources. What are linked data resources? Well, that's linked data projects. Linked data projects, those are sets of data grouped, sets of data models. I could have named it LD data model sets, okay, but I name it LD project. And this is not a link, it's a resource. So let's make it inherit from resource. And then we have a first kind of link. So some data sets can see other data sets. They depend on it. You can reuse data. We are linked data. So here I need a link to link projects together. What other data sets can this data set see? And that's the kind I'm defining here. No, that's not a resource, that's a link to link projects together, to make it one see another. And then I need another kind of link here, which is LD database link. Wow, what is that? Well, it's actually to specify very precise data store, such as if you're in a Mongo cluster, you may want to use a Mongo secondary to do data analytics in order not to hamper performance of standard uses of the Mongo primary database. So that's specifically for analytics, okay? And that's one of my main uses. So I'm defining here this link, and you will see later how it works. So what's a linked data project? I'm cheating here. I've got 3 attributes. Let's only write one. The name of the project. This is just a pretty way to do an eCorbines. Well, not an OCCI extension, which can be converted to an eCore. And we can also define actions. Actions are, okay, I'll give you an example. An action would be to publish a project so that it's available to be seen by other data projects. Meaning that its models are stable enough to be reused in another data project. And what would I need here on a database link? Well, something very useful, which is, for instance, the port of the database, so that I can know where to connect my linked data core. Here it is. And now you are going to ask me, fine, but wouldn't I need also a host? Good question, But actually, the target of this link will be an OCCI compute, which is a virtual machine and which has, in a generic manner, a host name attribute. So thanks to OCCI, we got the host for free. I don't have to define it here. OK, now that I've defined my extension, I can generate a lot of stuff.
You need an attribute for publish, not an action.
Oh, I did an attribute. Thanks, Etienne. Where is the action here? Here it is. So now I can generate EMF tooling. Yeah, it's a little slow, sorry. We can generate EMF tooling. We can generate, so what's EMF tooling? Well, EMF tooling are Java code that will allow us to manipulate in Java all the concepts that we have defined, LD project, link, LD database link. And we will be able also to edit it because we have generated here, we have generated linkdata1.edit project, which allows to graphically edit thanks to Eclipse Modeling. And we can also generate a lot of other stuff, such as runtime XML configuration, textile documentation, and alloy, that's a formal model, etc., etc., etc. I think I've got examples here of documentation. That's textile documentation for our link data extension. And we also have other kinds of editors, such as, yeah, that's the runtime XML configuration. So that's exactly what we just have defined graphically, but in an XML kind of way, because that's what our runtime wants. And you can yourself write your own generators and connectors to generate any other kind of format, such as an Amazon format, a Cloud Engine format, and so on. And we also have a DSL format, which I will show later. No, maybe Abby. I think, yeah, it's this one. It's this one. I found it. It's this one. It's this one. So we also have a DSL. If you only want to write it as code in a much more concise manner, you can do it here. And once all of that is done, you can go back to your eCore and generate the series designer. And this will generate the configuration of a graphical designer, which configuration you can graphically edit. So you've got a graphical modeler of a graphical modeler. A great OBO technology. They're standing just out there to the left. And here you can define how you will see projects, project links, containers, and so on. And there you just have to run the designer that you've just generated by right-clicking on your extension and saying run it as an Eclipse application. Here it goes. And we are back to where we started. And I will show you the live configurations that I just demonstrated. I am almost at the end of the presentation. If some of you want to go, no problem. Whenever you want. I think there's another one coming up next in 3 minutes. Yes, okay. So while it loads, I just want to say, so what we still have to do in OCCIware? More generators, more connectors at the studio level. We will also integrate, we are already integrating a simulator That's a tool made by an Australian researcher whose name I don't remember, sorry. And we are also developing, OBO is developing a decision-making tool to help companies decide whether they should or not go to the cloud by extracting their configuration, by extracting their IT configuration from their current IT infrastructure and doing some right-click refactor, replace all computes by AWS computes or Google Cloud Engine computes, and comparing both EMF models to compute how much it costs, how time it takes, and how many human resources you need. At runtime level, we will complete ossification of a multi-IaaS connector and of the RoboConf platform as a service manager. That's at runtime. And in between, we will complete an hierarchy bridge and an HTTP bridge so that connectors that already work in the studio will work seamlessly either in the hierarchy bus or standalone in lightweight way in HTTP. And finally, we have specified a monitoring solution and an OCCI Live Playground that will be available also for other OCCI implementation, not only for OCCIwares. And we will develop them. And obviously develop our use case and contribute back to OCCI 2.0. A question here? I think I've heard someone asking when it comes to Eclipse. No? Etienne, I'm sure you have asked that, no? Wouldn't you know? You're in the project like me.
So, still not yet stable enough to be an Eclipse version project. But at the end, it's possible that we provide a part of the designers as a new Eclipse project, or perhaps inside some existing Eclipse project like the Docker tools, or like in the cloud.
So, as I told you, here we have a VirtualBox virtual machine, and I can do actions such as right-click. I got too many stuff here. Right-click stop, and when it's stopped, I hope you're not impaired like I am, because can you see it's red? Yeah. It's red, great. And if I have a look in my VirtualBox machine here, I can do docker ps, and you can see that it just exited 20 seconds ago. Well, it works, wow. Let's start it back all again. And this is the same, but in an OpenStack, remote OpenStack machine. I can also do copy-pastes, link volumes from, and so on. And this is my software as a service configuration. So here, as you can see in my playground here, where is it here? Okay, I did not reset it, I guess. As you can see here, we only have GO0 and GO1 projects, okay? That's because only this one has been created, but not this one. So here, if I do an update, it will be created. Great. And moreover, it will propagate all configuration here. When we do analytics, we want to be robust. Well, it's read-only, so we don't care, but whatever. And we want to use a specific database, which is not the primary OSWille-Mongo 1, but a secondary OSWille-Mongo 2. And when we update, okay, it's been created, great. And as you can see, it's been updated. Well, my dates are all wrong here. As you can see, it's still 12 o'clock, but not a problem. And yeah, we've got a database URI here, which is Mongo 2. So we have propagated the URI and the host name, which had been defined at infrastructure level. So this is really, this had been defined first in the Docker configuration here. And what I did is only drag and drop it using here the left side tree panel. I dragged and dropped it here on the right. And that's how I was able to see it on this designer and link it. And now if we use the GeoAnalytics project, there's no data, but that's not a problem because I can actually use geodata here. And okay. Can't find model tab. Okay. Anyway, I'm way over the time, so I'm leaving it at that. If you want to have more information, you have just to go to the OBO stand, and we will be booth, and we will be happy to answer you. Hope you enjoyed it. Open to any questions. Thank you very much for attending.